This is Kolmogorov's equation. If you remember the first line, this is Kolmogorov's equation. No differentiation, no integration. We have a summation sign. You want to go from I to j in t plus h time. So t plus h means it's from 0 to t plus h, and then we have divided this way, 0 to t, then t to t plus h. I mean time. The states are I and j. You want to go from here to here. So I to k during this time t. This t means 0 to t. Then t to t plus h. The interval we write. Interval is h here. And this interval is t here. This is t, this is h. So this t in time t comes here, and time h comes here. Now this is the first line. We know this. So this is important, Kolmogorov's equation. Now from here, if you want to come to this line, if you check here, I've written Pij t, Pjjh. K belongs to state space. So here there could be 2 to 3, K1, K2, K3, whatever. All the options we have to find from I to j. All these options, and then we have to add all options. This one plus this one plus this one. There where summation comes. So Ik kj means k belongs to the state space. It could be any of these states. So one of them is j. Okay. Suppose I write this way. 1, 2, 3. Here 1, 2, then 3, here 1, 2, 3. Suppose you want to go from 2 to 3, or suppose 1 to 3, this one and this one. So one way is you go from 1 to 3, then 3 to 3. I to j and j to j. You don't change in the next interval. So this comes here. You go I to j in t time. It's like I want to go from Mumbai to Delhi through Hyderabad. What will happen is, suppose 5 hours given. In the first 3 hours I am here. Then the next 2 hours I will wait here, that way. This is one possible case. All other possible cases are here. All other possible cases, when we say this one in this example, this one and this one, these two are here in this summation, where k is not equal to j. The middle one is not the last one. So 2 and 1, they are not the last one. J is 3 here. So k is not equal to j. Here k is equal to j, or you can say j is equal to k, whatever. So this k belongs to s. We have divided into two parts. Here k belongs to s and k is equal to j. So I replaced k by j here. I don't need to write. However, there are so many terms here, so I have to write k is not equal to j. Most of the time you get a derivation in the exam, this derivation particularly, along with the problem. But recently, when we come to CS2, still there is a very less chance. Anyway, this one is copied here, and PJJH This we derived last time in the last class. So you write here. Similarly here P IKT we copied here, and this one PKJH, for that also we'll write here. Remember, we have 1 here, we don't have 1 here. That is the only difference, because the states match, so we write a 1 here. The states they don't match, so we don't write a 1 here. It's like 0 plus something. Then the next step is to multiply. This one you multiply with 1, you will get this term, and this one you multiply with this one. H is here anyway, P IJT and mu JJ, this term, the second term, plus order of H into anything is order of H, that is here. Even 1 order of H into this, that will come here, because anything multiplied by order of H gives you order of H. From here as well, anything multiplied by order of H, that gives order of H. When you add 2 order of H, you get another order of H. Now these are the 2 terms you have. Third term is a part of this one. Here within summation you have this one. The other part goes to order of H. Now we'll take this one to that side, this side, and we'll subtract. Then we'll divide by order of H. Sorry, we'll divide by H. So when you take this term that side, it comes here, and you have to divide by order of H. So this H will cancel here, no H, and from this side H is there, so there is no H here, there is no H, so H comes here. This is the normal way wherever you see derivation in CS2. Now we have to take limit. So when you take limit H tends to 0, there are 3 terms here, expressions. This is not one term. So the first term here, and the second expression this one, and the third one here. So when you take limit H tends to 0, this one will become 0, and then P IJT mu JJ plus this, that will be there. But we don't need to write separately now anymore, because here we have 1 term and here we have 2 terms. We divided for a reason. You can add these 2 and take out k is not equal to j. Okay, because everything is here. K is equal to j, k is not equal to j, 1 term, rest terms, in our example 2 terms, so all 3 terms we can write here. So will not write this one and will not write any condition. If you have 3 terms here, 1 comes here, 2 comes here. If you have 10 terms, 1 comes here, 9 comes here. That way. So this is our final equation, this one, and this gives differentiation of Pijt. Will not worry a lot about del upon del t, because out of fear only we use del, and we want to see the change with time. See t, that's why we write d by dt, but we write del because if you have some other thing which might change, we are not interested in that. We want to see the change when t changes. This is Kolmogorov's forward equation, forward differential equation, and we have backward differential equation, BDE. This is forward differential equation. Differentiation comes. Now we'll see how we can apply, but before going to the problems, if you check here, we are talking about I to j, I to k. So if you write I to j here, I to k will come here, then k to j. So in I to k, you have to write t here, remember. Now then here mu. Also in problems I will show you in the next class. There is a meaning between, there is a meaning when I say this is p and this is mu. I can clarify with the discrete example, and we'll come across these kind of problems in CS2, particularly in this chapter. Suppose you want to manage something whose interval is 0 to 20, and someone says, okay, what you can do is, you know how to manage 1 units of whatever. You have the ability to manage 1 units. Now, if I give you 20 units, then you can say this way, okay, let's divide this one into 2 parts. In the first unit, I have 0 to 19, and sorry, in the first part we have 0 to 19, and in the second part we have 0 to 19 to 20. A part of the problem is solved because you can manage 1 unit. Okay, so it's like taking 1 slice of bread. Okay, we can manage this one. How about this? Then instead of explaining time and again, you can say this is a recursion that will follow similar way. Whatever way we came from here to here, in the same way we can come here to here as well. That means 0 to 18 we can divide, then we can divide 18 to 19. So what will happen? Again, this is 1 unit, this can be done. How about 0 to 18? Again you divide this way. So the same thing follows time and again. This is what we do in recursion. Recursion means time and again the same kind of things will follow. So you need not say every time, you say one time. You will see in discrete case, this kind of things will become forward equations, not differential equations, forward equations. Forward means more here and less here, this kind of a division. We'll come across backward differential equations. In backward differential equations, it's not that we'll go back, we'll divide this way. 0 to 1, the smaller one is here, and 1 to 20. Then this can be done 1 unit, and 1 to 20 again you divide into 2 parts, 1 to 2, then 2 to 19. 0 to 1 is over, then 1 to 20, 1 to 2, 2 to 20. Okay, this is 18, this is 1. So this is possible, this is 1, this is 19, this way. This is called backward, this is called forward. Forward means initially you have a big one, then you have a small one. In case of continuous, we can say this way. Oh, sorry. I can write once again. When we say forward differential equation, remember, we'll use this big T. Means suppose you have 5 hours time, we are talking about 4 point, when I say T time, okay, there is no time mentioned here. Even I can write P and mu instead of T, P and mu. Here almost 4.9999 you can say, and here only 1 instant. Even there is no such time T2 comes, there is no time comes. Mu means instant mortality or instant intensity at that point. There is no time mentioned here. So most of the time we have divided 1 to 19. If you can compare with the discrete one, it's 1 to 19, and this is 1. This is instant and this is whole in forward differential equation. We'll see in the backward differential equation, mu will come here and P will come to the right. This is the forward differential equation. And when you form forward differential equations directly, remember you will get differentiation, then you have to solve this differential equation. But you have to form the differential equation to solve the differential equation. Now we'll also see today the usefulness of Kolmogorov equations. Very important. But let's try to form. So while forming the differential equation, don't think logically. You can think this one logically. This one. P ijt plus h, p ikt, p kjh, but not this one. If you want to derive from the first principle, you can derive without using this one also. You can start from line 1. You have 1 or 2 problems like that, even you get in the exam, not 1 or 2, maybe 10 or 8 or 10 problems you will come across where you will derive directly. We'll go to that later, but now we'll try to use this one, because in most of the problems you should be able to use this kind of an equation. Remember, ik, initially p, time t you have to write, then mu. Then you have to explore all states. Let's go back to the 3-state model, health, sickness and death model. Someone is healthy, that state is H here, and sickness here, death here, and all the intensities are given. These intensities, if you know, how you know these intensities, that's a separate thing. We are not going to that now. But for your information, if you remember, we know something about this already. It's not that you are totally new. You can estimate mu, sigma and all. This will come towards the end of this chapter. But remember, there was a small chapter where we talked about 2-state model and we estimated mu. That was 2-state model. Maybe you can say healthy and dead. You can write it as active and dead. There was no sick state. So there is a formula, mu cap. Time spent under observation, that way. From survey only we will have to estimate all this. We'll see the usefulness also, but yeah, this is the generator matrix. This one we have already formed this in the last class. Now we'll write the differential equation. Okay, there is a matrix form. Before going to the matrix form, we'll try to write one equation. Suppose you need to write h to h ij, p h. If you write, there are so many. See, this is the equation. Pij. Here in I have taken h, in j also I have taken h. It's not mentioned that j will always be different from I. Nothing like that. So I can take same also. If you write, you can write hs also. I've started with hht. Okay. You have to explore all possibilities. So phht. It's not an equation, so it's the differential equation. Del by del t comes. Remember what you can write. P, suppose you write p h, this is I j, then t you can write, then mu hh. There will be no t here. Okay, but we don't have concept of mu hh. So when it comes to hh, you have to decide. See the intensities we have here, whatever. If there is something, you can write. Okay, see hh mu we have in this example. We have, go to the diagram. Okay, we'll write that later. So let's explore all. The diagram also I copied. See, mu also exists for this one, minus sigma minus mu. We'll write that here, not a problem. So you have to explore all possibilities here. Somewhere there is a 0. When it comes to problem, you will be able to know, but wherever there is a possibility, you are supposed to write. So when you try to write each one by one, you will get all the possibilities. Here we have only two possibilities because this is only HH. You can go from H to S. Let me write all three in T time. You need to match this. And the third one I can write P H D, then mu D H. See HH here, these are matching. In between, whatever you want, you can write. This is not possible. This one is 0, so we will not write this term. We have only two terms here. Now, if you want to write the complete equation, let me write P H H T. We have a derivation for this one as well to find this, but it's not required now. Then mu HH, okay, the first one, minus sigma minus mu, if I'm not wrong. See, minus sigma, this is the mu, the first one. All are mu's here. Then plus SH, this one, here to here, okay, that is rho. This is the equation. Similarly, you can form PHS also, PHD also. All the equations, whatever is required, we'll see. We'll do one problem now. Before going to the problem, in the matrix form, the forward differential equation in the matrix form, d by dt of pt should be equal to pt multiplied by a. So I have written here, this will be more useful. This will be more useful. So when I say differentiation here, pt matrix you have to write. So d by dt we write this way, d by dt of ft. For that we write f dash t. This is the notation, mathematical notation. So here d by dt, for that I have written dash here, so forget about that. pt you have to write. This is your matrix pt. You start from 0, 0, 0, 0, 1, 0, 1, 1, 0, 1, 1, 1, and see, this is pt. And when you differentiate, just replace all the entries here by their dash, okay, dash here. So this is pt, this is d by dt pt, that is p dash t, and a comes here. A is here the generator matrix, okay, this is the generator matrix, and this is the matrix form. If you want to form an equation 0, 0 here, suppose all the equations are here, every equation you will get from here. Suppose the same one you want to use here, PHH, H means 0, the first one, 0, 0 t, okay, let's see where is P0, 0 t differentiation, the first one, this one, P0, 0, healthy is 0 here, so 0, 0 dash t, this is the left hand side. So in matrix, two matrices are equal if the entries are equal. There is only one entry here, you have to multiply, okay. So row column multiplication. So what will happen is P0, 0 dash t is equal to the first one, P0, 0 t, then mu 0, 0 plus P0, 1 t then the second one is mu 1 0. Then this one anyway p0 2t will not contribute because uh, let me write it, not here, plus p0 2t mu 2 0. 2 0 means death to healthy, this is not there, so anyway this will be 0. So these are the two terms and this is the equation. Okay, so all the equations, all the differential equations, all the forward differential equations are here in matrix form. So if you want, if you write this, there is no way anything will be left. Whenever you have the doubt, instead of writing directly, you can follow this matrix form. The first one I've written. If you want to write the second one, healthy to sickness, okay, healthy to healthy, the second one how can you get? This is the first entry. What is the first entry here? This one. What is the second entry right hand side? When you multiply, normally we multiply this way. This is the first term, and first one, second column, you will get the second entry. First one with the last column, you will get the last entry this way. So if you want to get this element, you need to get this element from the right hand side, that you will get when you multiply this. You can check also 0 0 0 1, that is finally 0 to 1. See, you are getting 0 to 1. Then 0 1 1 1, again 0 to 1, again here also 0 to n, n to 1. So the first one is 0, last one is 1, 0 to 1, 0 1. Anyway, let's go to a problem. This is the first kind of a problem, very small one, but yeah, we'll try to discuss it practically. A Markov jump process is two states labeled 0 and 1. These are the two states. Suppose state 0 is working in the company, state 1 is not working in the company anymore. These are the two states. You consider any company, a particular employee is working in this company. Okay, suppose you track someone now working in the company. What will happen after 6 months? Whether he will continue to work in the company or he will leave the company in 6 months time, you want to know. In 3 months time, whether he will continue to work in the company or he will not be a part of the company. That's what you want to know. So what is the question? Write down Kolmogorov's forward differential equation for this and solve this differential equation to obtain an expression for this. Okay, finally our task is to find p0 to 1. 0 to 1 means what is the probability that the person, this guy, will go from 0 to 1. 0 is with the company, 1 is not with the company. Okay, working with the company, and the second one is not working with the company. 0 to 1. Suppose you want to know after 1 month, after 2 months, after, sorry, this is 1, after 1 year, after 5 years, all you can find by substituting in t. If you know p01t, that means you know all this. So if you know p01t, you will know all this. Let me see the final one. And these are the transition intensities given in the question. But if you are doing something like this, you can always estimate this. This is statistics, this is survey. Here you have to use the method we discussed in one of our classes, maybe class 16th, two-state model. Remember the survey. That kind of a survey you have to make if you want to estimate these two. This is a problem, so these are given. So how to estimate the using the total time spent under observation, that way. Okay. So this is a problem, these are given. Okay, there is no solution, no problem, we'll solve it. we'll solve it and we find this one finally, then we'll be able to analyze this. Okay, so before solving this one, I would like to know the final answer here. So the final answer, if we know, that will definitely be helpful to discuss before finding the solution. Okay, for that let me erase all and write the final answer here within this box. One upon 11 1 minus now you can use a calculator and then you can find everything. Suppose you want to find what is the probability that one particular employee will leave the company 0 to 1. Probability of going, it's a two-state model, either you will get 0 to 0 or 0 to 1. If you start with 1, that's a separate thing. But considering that the person is working in the company now, what is the probability that in 1 year he will leave the company? Leave means going from 0 to 1 in 1 year. Just put 1 here. So you can use a calculator, e power minus 0.11, subtract this value from 1, then divide it by 11. That probability you will get. Suppose it's very high, I don't know even, suppose it's 0.89. So you can say that there is a very high probability that this guy, a particular guy, will leave the company. Then you should try to know why this is the situation. Okay, then you should try to do something so that this guy will not leave the company. If it's very low, then that's fine. Suppose you get it 0.01, there is only 1% chance that this person will leave the company in 1 year. Okay, that's very small. If you want, you can use a calculator and you try to know. But how to get this one? The final solution, we need to get it. Okay, so to get this one here, we have to solve Kolmogorov's differential equation. We have to form differential equation first of all, and we have to solve differential equation. We know how to form differential equation by now, so we'll form the differential equation. Even these are not given, we can do a survey and we can find this, and then we'll use this one here. Okay, that's a separate thing, but the first thing is to form the Kolmogorov differential equation, then we will solve it, then only we will be able to find it. Now there is a big question, why to do all this, okay, in Hindi, dramabazi, okay, why to do all this drama here? That is the question. Why not directly? Because we can also directly find P01. If you remember P, it's not that for the first time we are doing, we already found all this in previous chapters. There were so many problems, but we will not be able to find here because this is a continuous time process. If you remember what we have done before, we have never come across this kind of a problem. What we tried to do before is something like this. Sorry, this is not proper. In discrete time interval, the time is always equal, then only we can do something. The time interval should be equal. We wanted to know after each year. Suppose this is 1 year, this is 2 years, this is 3 years. Because this happens in years, okay, this is a discrete time stochastic process. Even if you consider a continuous time stochastic process, you can analyze it discretely. It's not that the processes are always discrete. So I can say one process. In general insurance company, talking about motor insurance policies, every year they rate, and they say they give you a rating. On that basis they give discounts. Now the question is, it will never happen somewhere here. This is a completely discrete time process. So typically we would like to know what is the probability that a particular person will go from here to here in 2 years time, say 2 years time, it's fixed. So what is the probability that one person will move from 0 to 2 in 2 years time? We write this way here. That's all. Either we'll find 1, that is normal transition matrix probability, 0 to 2, this probability. In 2 years time means we find p square, then we write this probability. Or sometimes we find 3 years time, 4 years time, that's all. Here what we want is, this is continuous. So we want to find P01T here. T could be 1 day, 1 second, 1 minute, 1 year, whatever. This is continuous time. This is different than this one. Here always if you see the problems, discrete time problems, either you find in 1 year, 2 year, 3 year, 4 year, 5 year, or you can say, to be specific, one time period. The period could be 1 hour as well, 1 hour, 2 hour, 3 hour, that way. So in discrete time stochastic process, we always analyze discretely. Even if it's a continuous time process, it doesn't matter. If you have a discrete time process, it's fine. If it's a continuous time process, then also it's fine. Suppose we talk about stock price. We are not interested continuous time stock price, though this is a continuous time process, but we analyze only each day. Okay, the end of price or the starting price, you can say, each day. We are not interested here how it's varying, but we are interested only here what will happen. Okay, after 1 day, after 2 days, after 3 days, that way. Even if it's the continuous, but we are interested to analyze in discrete time. Okay, so then also you can use the old concept. However, here this is a continuous time stochastic process. The employee we are talking about, he can leave the company anytime. It could be after 5 seconds. Okay, seconds will not come here. Maybe after 5 days or 7 days or 1 month or 1.5 months. All possibilities are there. Infinite possibilities are there. Mathematically, 3 seconds also there. Okay, you can put 3 here and you can find. We are dealing in continuous time process, and we can analyze continuously. I mean continuously when I say with an interval. What will happen after 6 months? What will happen after 7 months? What will happen after 7 months, 1 day? It's a continuous time process, and we can analyze discretely, continuously, both, if you are able to find this one. So how can you find this one, P01T? Only when you solve Kolmogorov's differential equation. So Kolmogorov's differential equation is so important. Without using Kolmogorov's equation, differential integral equations, will not be able to find and analyze this way. It's impossible. If you want to get something like this, the only way is to solve Kolmogorov's equations. There is no other way. Because directly we don't get all this. Directly we don't get all this. These are used. We'll see how we can use all this, but we'll use those in equations, and we'll try to solve differential equations. We should know how to solve differential equations as well. We'll use in this problem today one simple linear differential equation. Okay, so we'll try to solve a differential equation of this form, dy upon dx plus py. This is called first order, first degree linear differential equation. First order, first degree differential equation. Okay, order means there is no double differentiation. We have only single differentiation. We don't have a square cube also, degree, and also the derivative and y are not multiplied. That's why we have written separately in 2 terms. These are typical linear equations, and there is a formula, solution formula. We talk about integrating factor, we'll do that. Y if it's an indefinite integration, you can write a constant also. We have to integrate once again. Okay, we will use this solution method. We'll use this one, and we'll do this one today in today's class, and we'll try to derive that. Okay, then you will be able to know the utility of Kolmogorov's equation. Without Kolmogorov's equation, we can find. Why we can find? If you think further, if you go deep, where you get P01T? From where we get P01T? That is the question. You can never get, because if you remember the two-state model, we did a survey, we get only mu's. Remember, directly you can do some kind of survey and you can estimate only mu's. You can never estimate p's. Even if you can estimate p's, you will not be able to estimate infinite p's like this. It's impossible mathematically. They are infinite, and we never estimate these. So in continuous time process, these p's, they never exist. Even if you see the matrix, we said that transition matrix in discrete time process, transition matrix were the probabilities. They were consisted of probabilities. But here in generator matrix, these are the intensities. So the intensities we have, these you get from the survey. Okay, you don't get probabilities. To get probabilities from mu, so what we are doing is from mu you have to go to p, then only you can analyze. See, finally in this problem also we'll be finding p, and so what is that we are doing? We are trying to find p from mu. Where you get mu's? Mu's are estimated. These things you can get from the sample. Use sample in continuous time process to get mu. Use sample to get p's in discrete time process. Again I am repeating, in discrete time processes you can directly get the transition matrix. This I didn't teach. Okay, I need a class, that's how I numbered. I'll discuss some examples, some more problems, so that way I numbered. But I have to, because you are appearing in September, so I have to go very fast, so I'm continuing so that you will be able to do a lot of problems, but I will fill those gaps with more problems and examples. Remember, you estimate to get the transition probabilities. Okay, in transition matrix in discrete time. In continuous time only mu's are available. From mu we'll try to get p. So if you want to get p from mu, we use Kolmogorov's differential equation, forward backward, or integral equation, forward backward. 4 kind of equations are there to get p's from mu's. Now let's form the differential equation first. So this is the diagram. And initially when you see problem, this is of, you can say, intermediate type, because something more also will use, you have to remember in this class, but later you see when you do a lot of problems, these will be similar. So let's form the differential equation for this two-state model. Okay, Markov jump process has 2 states. We talk about jump process here. Jump process means in CS2 and in some statistical statistics books, you see we use jump word extra when it comes to continuous time, that's all. But jump process is not a separate thing here. Okay, so we'll form the differential equation, then we'll try to solve the differential as well. We'll do from a new page. Now let me write here. Sorry. the differential equation. It's very simple. It's a two-state model. 0 0 mu 0 1. Remember, there is no t here. When you write 0 1 0 1 0 0 0 1 0 1 t, then mu, see 0 to 1 finally, 0 to 1 mu 1 1, and this is given mu 0 1, so we'll write mu 0 1. I think that was 0.01, yeah, 0.01 0.10, okay, 0.01 p 00 t plus, but minus will come here because 1 1, the same means it will be minus 0.10. So again, see here the type of the equations, Kolmogorov's differential equations. Left hand side anyway p is there. In the right hand side you will get the terms where you will have p's and mu's. Mu's are the ones you get from your estimation. You estimate and you get mu's. So finally you get, see here in this line you have only p's. And this is a problem where you need to do a bit more than normally what you are supposed to do, because you have different things, P01, P00, P01, all that. So you have to express everything in terms of P01 because ultimately you need to get P01. Okay. So you see the terms where P01 are not there. We have one term P00T which is different. So we'll use simple this formula, P00 t is equal to 1 minus P01t, because if you add these two from 0, next time either you will go to 1 or you will stay in 0. Okay, the summation is 1. If you put that this here, okay, multiply and take everything to one side, then you will get this equation. You take that to the left hand side, so then P01t, this is the left hand side, and this will be 0 0 1 minus, you can verify this, because when you write 1 minus, that multiplied, that will give you this one, okay, minus this one. You can take common, I mean if you combine you will get this one. It's very easy. Now see, we have these two only, we'll write in that form. If you take dy upon dt, I have taken y P01t, then you take this one plus 0.11 y, this one, okay, then is equal to 0.01. Remember the general form, dy upon dx or dt plus py is equal to q. This is the general form of first order, first degree differential equation. And I have to find if, okay, here. If you have never solved these kind of differential equations, remember we talk about if. If is integrating factor. This is formula based, you just need to remember, that's all. Nothing more is required. But if you see in some other form, that you can always do e power integration p dx dt here, because t is the independent variable. P means this one, that will be e power dt, that will be e power 0.11 t, that's all. you have to integrate dt, that will give you t. So the solution for this is y if is equal to integration q if plus constant. If you make a definite integration, you need not write constant. There are two ways, but we can find the value of constant also from the initial condition. We'll see that. So y is here, p, we'll go to y later. So let me write y multiplied by if. If is e 0.11 t. This is if called integrating factor. We'll use only this method, so we'll not discuss more about this. Even if you are not from math background, not required, just remember this formula. Every time you get this way, y separately, and then dy by dx some coefficient. Then q is the right hand side, 0.01, and you have to integrate once more. Okay, whatever you get, this one you need to integrate. If you integrate this one, e power at, e power 0.11 t divided by 0.11 you will get. Okay, then plus c, I integrated already, plus c. Now if you put y value here, y was p01 t, that is equal to, when you divide, if you multiply by 100 here, 1 upon 11, right? E power 0 t plus constant. I think I have to write this one as well. Y is p01 t, then you write p0.11 t. Then you are supposed to find the value of the constant c. Remember this one. Then you have to find the constant value of the constant c. To find the value of the constant c, you can take you put t0. Suppose if you put t0, what is p010? Impossible, right? This will be 0. So if you put t0, 0 will be equal to 1 upon 11, e power 0 is 1 plus c. So that means c is minus 1 upon 11. Okay, and put c here, then take common, put c minus 1 upon 11. So we'll have this one, c is minus 1 upon 11, minus 1 if I am not wrong. Then you have to take this one as well. So p01 t will be equal to 1 upon 11. You can multiply this one. This will be 1 minus e power minus 0.11 t. This is what we are supposed to get. p01 t is equal to 1 upon 11, 1 minus e power minus 0.1 t. So this you get when you solve the differential equation. Okay, Kolmogorov's differential equation, and all p's are there. When you are solving for 0, 1, remember, if you might get to solve around 20 problems for your differential equation. So in each problem, for whatever you are solving, you have to make that is your y. That means, going back to the original equation, here you see how many types are here, p's. This is one type, and even you want to get this, the other type is this. So always you can use this kind of an equality. I mean, I must have erased that. So to transfer this one to this one, so make everything in this way, then in 99% of the cases, maybe I'm not sure 100% of the cases, you will get equations in this form only. Now you can solve this one to get y. That is what you want.